This single-purpose high-low gauge performs several of the same functions of the high-low welding gauge. With this gauge, you can measure internal misalignment and fit-up gap after fit-up. First, we'll measure an internal misalignment. Loosen the retaining screw and extend the legs beyond the housing of the gauge. Now insert the legs into the fit-up gap and rotate the gauge 90 degrees. With the gauge housing held squarely against the pipe wall, the internal misalignment can be read from this scale. We can use the opposite end of the gauge to measure the fit-up gap. First, loosen the retaining screw and insert the gauge into the gap so that the leg with the less taper will rest on the pipe bevel. The other leg can be extended until it contacts both pieces of the pipe. Now tighten the retaining screw and remove the gauge to read the fit-up gap measurement on the scale. The VWAC gauge is a tool which allows you to perform several different types of measurements and to compare weld defects. With this tool you can measure undercuts or pits, reinforcement of butt welds, outside misalignment, surface porosity per linear inch, and compare surface porosity for size. To measure an area of undercut, set the bottom of the gauge on the base material. Set the tip of the pointer into the area of undercut and read the amount of undercut from this scale. The locking screw can be tightened to hold readings for future references. To measure the weld reinforcement of a butt weld, set the bottom of the gauge on the base material and set the tip of the pointer on the top center of the butt weld. Read the height of the weld on this scale. To measure outside misalignment, set the bottom of the gauge on one member or spool piece. Extend the tip of the pointer to the adjacent spool piece and press the tip of the pointer up or down to make contact. The reading from this scale will give you the amount of misalignment. To measure a line surface porosity in 1 linear inch, place the end of the gauge with the scale along the length of the weld to be examined. Read the amount of aligned pores in 1 linear inch from the scale with 1/16 of an inch increments. To compare surface porosity for size, place either the 1/8 inch or the 1/16 inch hole in the gauge next to the pore in the weld to be checked. Compare the size of the pores to holes in the gauge. The adjustable fillet weld gauge was designed so that just one gauge can be used to check 15 different sizes of fillet welds, equal or unequal in size. With this gauge, you can measure fillet weld leg lengths from 1/8 of an inch to 1 inch in 1/32 of an inch increments, desired throat thickness of fillet welds, and unequal legged fillet welds. The strength of a fillet weld is based on the effective throat thickness, which is the shortest distance from the root to the face of the weld. For an equal leg, 45-degree fillet weld, the throat is 707 thousandths, which is the sine of 45 degrees times the leg size of the weld. To measure equal-legged fillet welds to size, as required from drawings or specifications, select the appropriate size. In this case, a 3/8 of an inch fillet weld is required. Set the 45-degree slide at 375 thousandths of an inch, or 3/8 of an inch on the scale. Place the gauge on the horizontal member. Slide forward until the bottom of the irregular curved portion touches the toe of the weld. At this point, the bottom of the 45-degree slide will contact the toe of the weld on the vertical member, which indicates that a 3/8 by 3/8 of an inch fillet weld has been verified according to specifications. To measure throat thickness, a welder must determine weld leg sizes. If 3/8 of an inch fillet size is required, use 707 thousandths times leg length formula in determining the throat thickness. For example, 707 thousandths times 375 thousandths equals 265 thousandths. Round this off to the nearest fraction in 1/16 of an inch, which would equal 250 thousandths, or 1/4 of an inch throat thickness. To determine this measurement, move the slide to the center of the gauge at the throat and check position. Extend the pointer to 250 thousandths of an inch and lock the screw. Place the gauge so that the 45-degree legs touch horizontal and vertical members. The point of the extended slide should just touch the face of the throat as shown in this example A. If it does not touch as shown in the example B, more weld is required. To measure unequal-legged fillet weld size, determine from specifications the size required. In this case, a 1/2 inch by 3/8 inch weld is required, as shown in example C. Set the 45-degree sliding scale at a 1/2 inch and set the small back scale at 1/8 of an inch and lock the screw. Then proceed in the manner just described for the equal-legged fillet weld. Another type of weld defect encountered is undercut that is transverse to the primary stress in the part that is undercut. To measure this weld defect, the weld transverse primary stress, or WTPS, undercut gauge is used. To measure undercut, place the gauge on the surface of the member next to the undercut area. Insert the 10,000ths tip into the undercut. With the aid of illumination, determine if light can be seen between the parallel surfaces of the gauge and the base material. If light can be seen between the two parallel surfaces of the gauge and the base surface, the area is acceptable. If no light can be seen, the area is just at 10,000ths, or rejectable. The WTPS gauge kit includes a precision calibration block for periodic calibration. The final gauge demonstrated in this program will be the skewed T fillet weld gauge with calculator. Normally, we think of members being welded together at a 90-degree angle to each other. A special condition exists when members come together and are welded at angles other than 90 degrees, and fillet welds are used to make the connection. These conditions are called skewed T-joints. The angles involved usually are at a 60-degree angle minimum on the acute side and 120-degree angle on the obtuse side. The 60-degree minimum angle requirement is specified on the acute side of the joint to allow for access of the electrode by the welder. Here we are measuring the W dimension of a fillet weld in the skewed T-joint from the obtuse side of the member. Here we are measuring the W dimension of a fillet weld in a skewed T-joint from the acute side of the member. The W dimension that is used for the inspection of the skewed T fillet weld sizes can easily be found by using the calculator. Leg size can also be obtained by using this method in conjunction with the gauge. This concludes the presentation of the various weld inspection gauges used by the personnel responsible for the dimensional requirements in conformance with the national welding standards.